Right. So one of the topics that we need to look at, I actually want to do collections next. But before we get into collections, one of the topics that I want to cover with you is something called as generics in .NET. Okay. And generics, you would have probably been introduced to this in Java as well. So it's a similar topic. But let's have a look at it from a .NET perspective. So generics is required in situations where you have similar code in different classes with only the data type being different and all the other code that you're writing assuming it's the same type of code. Like have a look at these two classes. I have a class here called int functions and I have a class here called decimal functions. So these are functions that you might want to do with an int and these are functions that you might want to do with a decimal. And if you look at the code in here, it takes, the swap function, which one takes an int as a parameter, one which takes a decimal as a parameter. You'll notice that the code is identical in both of these. Okay. The only thing different in the code is the data type that you're actually using. Now, if you had other classes which had some similar code, like let's say maybe there was a class called bool functions, and bool functions is instead of using a int or a decimal, is using a bool. And if you had other data types, for example, the code in here will remain exactly the same. But what's going to change, of course, is the different data types that you have in these different classes. Now, to avoid having to create multiple such classes, which each of these having a different data type, we can think of creating one class, a single class, and use a generic data type. Now, when we use a generic data type, at the time of writing a class, we are not specifying what type, data type, what specific data type it is. But when we create an object of that class, that's where we actually would specify the data type that we'd like to use out. And that, in a sense, is what generics is all about. If you're coming from a C++ background, there you had to consider templates. And templates also do something similar to this. So let's see how we can work with this. Prerequisite, of course, is that the code that you're writing for all these different classes has to be exactly the same. No changes in the code. Only change that is allowed is a change in the data type. So I have gone for a new project for generics example. I already have a class that I've created for you, and take a minute to go through the class and tell me what uh, you know what changes I'm going to ask you out here. So just see what is happening right now in this class, and then I'll discuss this as well. So if you can make out what is happening in here, it's actually I'm simulating a stack of integers. To do that, I've created an integer array. So it's a fixed size stack. And the initial size of the stack is being received as a parameter here. Array getting initialized to that stack. Position keeping track of where is the pointer pointing to, the last, the top element on the stack. And every time I do a push, I'm incrementing the position by 1. And every time I do a pop, I return the value, and then of course I decrease the position by 1. So this is a fairly standard code that I've written here for a integer array. Any questions about this code? I will clear about what this code does.
No, sir.
So my question to you then would be, if tomorrow if I want to create another stack, let's say I want to create a stack of strings. Can you suggest to me the changes that I need to make in my code to make it also work for a stack of strings instead of a stack of integers? Tell me the line number that I need to make a change and tell me what change I need to make.
32
What change?
into string.
Okay, next.
33 int size to int string size.
Are you sure?
No, sir.
No,
It will
it will
be
be
number
number
35.
35.
It will be integer.
Line number
Because this
35
here is
new
not
string.
the, this is the size, one second, this is the size of the array. So size of the array would be an integer. Okay, next change, 35, correct. So replacing the int by a string. Next change,
38.
In push,
44.
we have to push a string.
yeah, before
38
before
34.
44, there was a 38 that I heard.
Yes, sir.
So push a string in here. And then yes, 44, correct, returns a string. So I think that sort of covers everything. All right. Now, if I wanted to create a decimal stack, all that I do is what? Replace the word string with decimal, right? So you could then create other stacks here. So I'm not interested in creating separate classes here. What I want to do is I want to create a generic class. Okay, a generic class. And let's see how we could do this. So I'm calling this as my stack. Okay. And the generic type can be given immediately after that in angle brackets. So my stack of T. You're reading it, read it as my stack, the angular brackets is of T. So what is this saying now? This is saying that the data type that I'm using here is a generic data type, which will be passed when you're creating an object of this class. And this is the data type that I want to use. So T, I mean, T, there's no syntax here. T can be anything, X, Y, Z, A, B, C, D, whatever variable name that you want to keep, you could keep that. So my stack of T, and what I'm going to do here is wherever you find string, replace that with the variable T. So it's a T array, and T will be passed to me by the user who's creating an object of my class. So again, the same suggestions that you all gave me a few minutes back, I'm going to implement the same thing, but this time use T. Again, T, and return type again is T. So now this variable will be passed to me when I'm creating an object of the class. Let's come back to main and try doing this. My stack of T now will be replaced with the actual data type. So in the first example, I'm taking int, let's say O1 is equal to new my stack of int. And then of course, when you're creating the object, it's asking you for the constructor, it's asking you for the size out here. Size is, let's say 3, for example. Now, wherever you pass int out here, wherever you see the word T, T will be replaced with what?
Int.
For an int. And that's how the compiler will compile the code. Now, all of this would be done at compile time itself. So initially itself, it will know what the values it would be. And let's try calling the methods now. So O1 dot methods that I'm calling, one is the push. So push here, if you look at this line number 61, was push of T. But that push of T, when you're trying to call it now, has been replaced with what? Push
Int.
of int.
Int.
So why int? Why int?
Because while creating the object, we have created the method as int.
Correct. So line number 7 was an int. So this became an int. Supposing line number 7 used a string, this push would now take a string. So depending on the type that you're passing, it would now take that type. So let's pass some values, push of 10, 20, 30. Right. I have also written code here which says if I pass more than the size, then keep a check whether the stack is, the array size is being exceeded or not, and then if there's nothing to return, then if you try to pop something, then keep a check and say that the stack is empty. And all of those checks I've done, you can try them in the lab. Console.writeLine again o.pop. O.pop now again is returning what? Returning a int.
Integer.
So instead of normally, if you look at o.pop, now it's returning an int. Here it is actually returning a t. The t has been replaced by an int similarly. Pop. Okay. If you try running this code, then values you should get a 10, 20, 30 being reversed as 30, 20, 10. All right. Any questions, any doubts on any of this? Anything that you would like to ask before we take it forward?
Hello, sir.
Yes. Yes.
Sir, can you summarize some major difference between this generics and the bar keyword in terms of implementation point of view? Some major
Between generics
and the bar keyword.
what keyword?
That bar keyword, BAR, bar keyword.
Bar keyword, BAR.
Yeah,
I don't have any bar keyword in .NET, so I'm not sure what you're referring.
I came across that keyword in the PDF now, sir. That any data type can be taken if we declare a variable with bar keyword like that.
Where
So,
VAR. Okay, I'm
yeah.
sorry, I heard BAR. Okay, I will be
Okay,
covering VAR a little later, but generics is an entirely different concept. So I will
okay,
be covering that's called as a implicit variable, and I'll give you one line explanation right now, but I will explain it later when I'm taking a session on that. So the var keyword will take its value based on the value that you give on the right hand side. So whatever you initialize it with, it will take that data type. That is entirely different from generics. Okay.
okay,
So it's a
okay, sir.
different concept, and I am going to cover that, but not in this session. I will be covering that in
Okay,
probably on Monday. I will cover it.
okay, sorry,
Most probably
sir.
on Monday. All right. Yeah. I did cover the var keyword. I don't think I covered it, but we saw the var keyword when we did the array example and you wrote a for each
In the
loop,
for each loop, yes.
right? So yeah, if that's what you're referring to, we will be covering that in a later example. All right. Let's look at the other possibility here. Instead of creating an my stack of int, I'm going to create a my stack of string. So can you please help me with this code? Just you can read up the code from top, and instead of int, tell me about what to do with the string. So my stack of this
String.
changes to what?
String.
String.
You can refer to the earlier line of code, and
O,
would give you
O2
idea of what to
equals
do. O2 is equal
equals
to
to new my stack.
new my stack of string and into bracket 3. What are the 3 out there? That's the
Size.
constructor. That's the size that we are having. And similarly, if I did o2.push now, right? So you'll find that it takes a string as a parameter. O2.push is taking a string as a parameter. So that is automatically changed based on the data type that you had out here. Whatever, let's say push up, whatever else. Push bar, maybe push bar, maybe. And it prompts me with what? I thought it remained to this, it's just not. So let me just copy paste this one. Okay. So similarly, you could work with a string as well. All right. Now, when you create a generic constraint, like here in the class, it can take up any type of data. Right now, it can take up any type of data. But you can also restrict what type of data can be passed by using what are known as generic constraints. So check this out. This is an example of a generic constraint. I'm saying class by stack of t, where t colon class, a t colon class. So what do you understand by t colon class? What do you think this would do? Where t is a class, t colon class. What do you think this would do?
Will restrict it to class types,
What are another word for class types?
reference type.
Correct. Absolutely correct. Very well said. Good answer. So now when I said where t colon class, it now is putting in a constraint which says that the only thing that will be allowed here would be a reference type. So if I go to the code on top, you'll find that this line is not working because int is a value type. Okay. And if you come back here, just like you have where t colon class, the other option that you could do is what? Where t colon struct. So what do you think this would do?
Restrict it to struct type, value based type.
To a value type, where t colon struct. So make sure that this is a value type. So now if I go back on top, your int works fine, but what is not working is the string.
String.
So you have 5 such constraints, and let's look at some of these constraints. So we've seen the first two, where t colon class, where t must be a reference type, or where t colon struct, where t must be a value type. Look at the next one, where t colon a specific class name. So for example, if I said where t colon employee, you'll have been creating those employee classes and the derived classes of employees yesterday, day before. And I said where t colon class name. So here the restriction is it must be either that class name or any of its derived classes. So t colon class name must be either, like if I said t colon employee, you could either pass it employee or any of the derived classes that you created from employee. Are we clear on this? Yeah. Any questions
Didn't
about
got the
this?
point. Can you repeat it again?
Let's say I said where t colon employee. Then I put this constraint. It says that what you're passing in here when you're creating an object, this here must be either the employee class or, complete my words, either employee or
Derived class of
a
Class
employee.
name and
derived
derived
class,
class.
a derived class of employee. So that's your constraint. So you're giving a specific class name out. Are we clear?
Yes, sir.
Okay. Similarly, you could say where t colon interface name. So supposing my code was where t colon IDB functions. Now what can I pass out here? I can pass it in any class that implements that interface. So if I had given, for example, where t colon IDB functions, here I could pass it any class that is implementing IDB functions. No other classes will be accepted. Are we clear on this, everybody? With the interface theme? Yes, no.
Yes, sir.
The fifth constraint is where t colon new, and new here indicates that you are trying to call a no parameter constructor. So if you give where t colon new, the constraint is that that class or struct must have a no parameter constructor. You must have a way of creating that object of the class without without passing any values in the constructor. So that line should be supported on. Are we clear on this? Yes, no.
Yes, yes, sir.
So,
All right. So these are the 5 constraints that you can have, and you can also combine constraints. So, for example, if you look at this line 77, where t colon class name comma interface name implies what?
It can implement a class or an interface, or a class
No,
that
no.
implements
It
it.
right. So you're saying that what you're passing here must be either that class or a derived class of that class, and it must also implement the interface that we are giving out here. So both the conditions should be true, and only then it will be allowing it to pass that. Okay. In the next one, I've added the third condition as well. It says what? Should be that class or a derived class, must implement that interface, and additionally must also have a no parameter constructor. These are the things that you would have out here while creating a constraint. Now, if you are also giving new, then new must appear at the end. That means new must be the last parameter. I can't do this. This would result in a syntax error. Okay. This would result in a syntax error. Are we clear on this, everybody?
Yes, sir.
All right. Also, I mean, logically speaking, I can't give something that's contradictory. Like, for example, I can't say where t colon class comma struct. That wouldn't make sense, would it? Supposing I wrote where t colon class comma struct. That means what? It must be a reference type, and it also at the same time must be a value type. So there's nothing like this that is a reference type and a value type there. So that's what your constraint could be. Okay, you can't give in a constraint which sort of doesn't make sense. Okay. Now, when you're using generics in .NET, a majority of the time, maximum amount of time, you will not end up creating the classes that are using generics, but more often than not, you'll be using an object of an existing class. So this code will happen more. Line number 7 onwards, that type of code will happen more. What you did later, which is creating the generic class, that is probably less chance of you having to write such generic classes. So anyway, that's how you can work with generics in .NET. Any questions before we move on to the next topic? All right. So the next topic that we're moving on to is one of the most widely used topics in .NET. One of the topics that will, in all the code that we'll write after this, from now this point on, we'll be using this code in some way or the other. What we are talking about is the using of collections. So we saw yesterday how we could work with an array, right? Now, instead of an array, we're going to now try working with a collection. So first question, how are collections different from arrays?
Collection is a collection of data, objects, while array is a collection of data types.
No, I can have an array of objects. No? I can have an array of employees. I can have an array of object types. So that is not the correct answer.
Sir, but they are of same data
Collection is a
type.
container which having an
Flexibility.
object.
A fixed
The
size and
collection works with
non-fixed.
That is the difference. The
Unit of
last
object.
answer that I heard is the answer I'm looking out for. Basically, when you give an array, the
Similar data.
number of elements that you can hold in the array are fixed. So supposing you create an array of size 5, it will always hold 5 elements without you, whether you need them or not. Even if you need to store only 2 elements, it will still create an array of size 5, whatever size that you're giving in the beginning. Collections, on the other hand, are more dynamic and more flexible. So as you keep adding different objects in your collection, the collection size will keep increasing. It's not going to be a fixed size to begin with. It will dynamically change. So which means you can easily add elements to a collection and the collection automatically grows in size. But that's not true for an array. An array would have a fixed size. Similarly, you can also, if required, delete elements from a collection and the collection reduces in size. You can't delete elements from an array, for example. You can also, for collections, insert elements in between, right, which you can't do with an array, right? So collections are a lot more flexible than arrays in terms of how you're interacting with the user, how you're working with the data, adding more elements if required, removing elements if required. All of this would happen very easily with a collection. Okay. In .NET, you have broadly 2 collections, right? You have 2 basic types of collections. You have the generic collections and the second one is the non-generic collections. So we'll look at both. We'll start with the non-generic collections in .NET and then in the later example, we'll look at what are the generic collections, right? So generic collections would be wherein you can specify your data types. Okay, I want a collection of this. I want a collection of integers, I want a collection of strings, I want a collection of whatever, employee object, whatever. But non-generic collections would not allow you to do that. So we look at both because both are obviously used in .NET. You need to know both. Every collection that you create in .NET implements the iCollection interface. So what you see in blue out here, beginning with the letter I, all of these are interfaces. And what you see in black out here are classes that implement that interface. Okay. So I'm starting off with iCollection. I'm saying iCollection is the collection or is the interface that all collections will be implementing. The methods in there will be available to all collections. iCollection inherits from IEnumerable. Therefore, iCollection gets all the methods of IEnumerable also. Right? Have you all tried inheritance in interfaces? I had asked you to try that out. Remember?
Yes,
I1, right?
Yes.
So something similar. So iCollection inherits from IEnumerable and gets all its methods. And the IEnumerable interface allows you to iterate through the object that you're
each.
using a for each loop. So that facility will also be available for a collection where you can iterate through the collection using a for each loop. Remember, we did that with arrays. An array also implements IEnumerable. Therefore, this would also be required of you, in collections to loop through the elements out here. There are two further interfaces, iList and iDictionary. iList also inherits from collection, and so does iDictionary. iDictionary also inherits from collection. So whatever the the base methods in the collections are also available in iList and iDictionary. Right? What is the basic difference between a list and a dictionary? What is the
Dictionary has key value pairs.
and list? List has
List,
what?
list has only elements.
Right. So in the list, you would only have the different elements one after the other being added. So for example, you could have a list of, let's say, integers, a list of strings, and so on and so forth. You could do that. But a dictionary object will have in each entry, you will have two values out there. You will have a key and a value. Key and a value. Key value pair it's called as. Right? Using the keys, you will identify that element, and value will give you the actual value for that element. Keys are unique in a collection. You can't have duplicate keys in the collection. Like for example, in case I have to store student details. So what is the one thing that all of you students would have which is unique in your case?
Roll numbers.
Right? Roll numbers or whatever. I mean, in CDAC, what are they called? Are they called PRN numbers?
PRN numbers.
Yeah. So if you're joined for CDAC, your PRN number would be your unique ID. And then the value would be the actual other student data that you might want to store in there. So that's your combination of keys and values in a dictionary. Okay. The classes that we have shown below that, all of them implement that. Like for example, an array list implements a iList. A sorted list or a hash table implements a iDictionary. Stack and queue are examples of classes that implement iCollection. So we're going to be looking at some of them. This is not the entire list, of course. You have more collection classes, but these are the commonly used ones that you use quite frequently while working with collections. So let's have a look at some of these classes. Any questions before we jump into the code?
Do iList and iDictionary implement iCollection?
Yeah, they inherit from iCollection.
Okay.
The hierarchy is the topmost interface is IEnumerable. iCollection inherits from IEnumerable. iList and iDictionary both inherit from iCollection. So they will also get the iCollection methods. And obviously they will also get the IEnumerable methods. Okay?
Yes.
Yeah. Any other queries? So let's switch over to the code and try some of the code. Now if you can see the the namespace where this is located, what is the namespace?
Using
System dot
collection.
collections. So we are going to use that namespace out here. Right, and let's try using this. So in my first example, I'm going to take up an array list. Okay. Start with an array list. Okay. You'd be, as I said, encountering collections a lot in .NET, and most collections, would have these three methods that you typically work with. They would have an add method by which you can add something to a collection. They'll have a remove method by which you can remove something from a collection. And they would have a count property, which tells you how many elements are there in the collection. So these three are standard options everywhere: add, remove, and count. So let's start with an add first. Obj array list dot add. See what it takes as a parameter.
Object
What's it?
obj array list.
Not obj array. I'm asking what does it take as a parameter?
Object.
Don't read that line. Don't read that line. Read this line. What is it taking as a parameter?
Object.
Object.
It takes an object as a parameter. So basically you can add anything that you want to this array list. Let's start by adding, let's say, a number. Similarly, I can add maybe a string. Right? So different data types that can be added out here. Right? So what I'm doing out here is I'm adding different data types out here for your array list. Now, by default, all the items are added at the end of the array list. So if I add this, it's adding it in the first element. This will be added to the second. If this becomes the third element, this becomes the fourth element. You're adding it to the end of the array list by default. If you'd like to add it in between, so obj array list also has an insert method. What are the two parameters of insert?
Index and object.
Index and object.
Right. So at what position you want to insert it, or the index, and what is the value that you would like to insert? So where is this being inserted now? Not at the end of the list. Where would this be inserted?
Zeroth index, first
Zeroth
position.
index. First position.
Zeroth index, which is the first position. So what happens to the indexes once you insert it at the zeroth one? What happens to the other indexes?
It will move.
Shifted by one.
Shifted towards right.
They all shift down. They all shift by one. So that's your insert method. Of course, you can try inserting at whatever location. So insert at one would insert it where now? Between what and what? Between
10 and Vikram.
10 and Vikram.
10 and
Right? So it would insert it there. You can try out all of this. You have to try all this in the lab. Now, you also have add range. The add range takes what as a parameter? See this? What does it take as a parameter?
Collection.
I collection.
Okay, it's not collection, it is actually
I collection.
I collection. So which classes implement I collection out here? Can you tell me?
Stack and queue.
Second.
Only stack and queue?
Array list, hash table, and
Array
sorted
list
list.
has to.
All of them.
Yeah.
All right. Because I list inherits from I collection. So I list would also have what the methods of I collection. So does array list also implement I collection? Answer is yes. Does hash table and sorted list also implement I collection? Answer is yes. So basically all collections implement I collection. And here I can pass it an I collection. Basically I can pass it an object of any collection out here. And that will be added to that. So let me take up obj array list 2. I don't have array list 2. What will that do? What will that do? Supposing array list 2 has 3 elements. So what will happen now? What will
Array
add
list,
range do?
object array list to will be added to array list.
At the
The
end.
items in the obj array list 2, all individual items will be added one by one in the obj array list. It's not the whole array list being added. It's an add range we are calling. So one by one, all the items will be added to the array list. Are we clear on this?
Yes, sir.
Yes.
Yes, sir.
Just like you have an add range, you would also have what? You have add and insert. You can also have what? Add range and what else?
Add all.
No, no. Add and insert you are having. Add is there, insert is there. So just like you have add range, you should also have what?
Remove or delete.
Insert range. Add insert. Add range,
Insert.
what is? Insert range. So all of this is very logical and very, follow certain this. Insert range, what will be the parameters?
Index and the array list.
Index and the collection.
Section.
Correct? I collection. So where is it inserting? Assuming obj array list had 3 items. Where will the 3 items be inserted?
Index 0, 1, and 2.
Index 0.
Yeah, correct. Index 0, 1, 2 is a more complete answer. Even index 0 I'll accept, but index 0, 1, 2 is where it will be added. And the other items will all shift down. Okay, so you have to try out all this. Don't take my word for it. You have to try out all this in the lab. So that's how we could add items to a list. Now to remove items from a list, obj array list dot would have the remove method. So let's start with remove 10. And you also have a remove at 10. Can you tell me what will be the difference between remove 10 and remove at 10?
Remove 10 will look for the element 10, while add will look at the index 10.
I couldn't put it better. This is what you're looking at. Remove at refers to the index. Now, do I have 10 elements in here? Do I have 10 elements in here?
No, sir.
So if you try running this code, it will give you an error because, obviously index out of range. Okay, but if you had that many elements, you can try it. You also have a remove range. Any guesses what that would do? Remove range.
It will take a 2 index and remove from that index to the other index.
Partly correct. So what it does is it gives you firstly the index, the starting point it gives you. But the second parameter is number of items to remove. It's not from to. It is from and how many items to remove. The count of the items to remove. Okay, so slight difference from what you said. So if I said 0, 3, if it was from 2, it will remove 4 items by 4. 0, 1, 2, and 3. If it was from and 2, but it is not from and 2. It is from 0, remove what? Remove
3 elements.
3 elements.
3 elements. Are we clear on this?
Yes, sir.
So I'm not doing that. I'm not doing that. But when you're in the lab, you could actually try it. So this actually is what? Index and count. How many items to remove? Let's try printing the number of items. So again, you have obj array list dot count, which will tell you the number of items. Again, this add, remove, and count, you need to be very familiar with. You'll be using this very frequently. Okay. All right. Let's try looping through this and showing the elements. To loop through this, what do we have again? We have the for each loop. What's my collection here in this case? Name of the collection is
which array list.
obj array list, right? And instead of var, what is adding to this array list? What does it take as a parameter? What is the
Object.
data type? Correct,
Object.
Object.
So each element in the array list is an object. And console.write line. Are we clear on this?
Yes, sir.
Yes, sir.
Okay. Let's try quickly printing this. So I have added 5 elements. New, of course, is added in between, and then it should show you the count as 5, and it should show you the elements that have been added into that. All right. Questions, of any at this point?
So while using the add method, you showed that it is showing obj question mark. That is, it is accepting nullable values, right?
Hmm.
So it can store null values. But my question is, anyhow, we are storing object over here. That integer will also be converted into some object type, if I'm not wrong. Then anyhow,
Yeah.
it will
So
accept the null values. So why this question mark or
okay.
nullable
So
property?
I have not covered I have covered nullable types with you yesterday, but I said the nullable types would be all integer types, would be all value types. So I have not covered what are nullable reference types. I will cover that in a later session. Right now, just
Okay.
ignore it.
Okay.
Right now, don't worry about the question mark that it shows you. Somewhere else, it might be showing you string question mark also.
Okay.
So ignore the question marks there. I will cover this concept with you, but let me first, now I'm in the middle of this, let me complete this example, and maybe in the next session I can explain to you what are nullable reference types and when you need to use them and why you don't need to use them also. So all of that discussion I'll have in one of the later sessions.
Sure, sir. Thank
Okay, but for now just ignore. Just just ignore the question mark if you see it ahead of a reference type. Okay. Let's try a few other things here with the obj array list. So let's see some of the methods. Add we have tried, add range we have tried. So you'll find some methods which are shown with a down arrow. And I would like you to ignore all those methods because those are methods that you're going to use in link. Right. So as parallel, for example, is something called an p-link and so on and so forth. So these concepts again, I will be covering with you, but in later session. They're a little advanced concept. So not right now. It's too early to cover that. All right. Binary search, index of and last index of. Have you all tried this with an array? Binary search, index of and last index of. Have you all done it with an array?
Yes.
Yes, sir.
you. Yes, sir.
Yesterday's example, did I cover jagged arrays with you all?
Yes, you covered
Yes.
that.
Yeah,
Yes,
okay.
sir.
So I was not sure because I'm doing 3 parallel batches. So I'm not sure in which batch I had covered what. So anyway, so you know the array methods, index of, last index of, and binary search. They return the index of that item that was found. If not found, is returning what? In case of index of and last index of, what does it return if not found?
Minus one.
One.
Minus 1. So these are methods that are common to what you did in an array. So I'm just going to write down the method, but I'm not going to, you know, explain that here because this explanation is identical to what you did with an array. If you have any questions, ask me. But otherwise, I'm presuming that these are things that you are already familiar with.
Sir, I have a question. Maybe it's a bit irrelevant. Can I ask?
Yeah, I'll tell you if it is something that I'm not going to answer. I'll tell
Uh,
you.
yes, at line number 9, we are passing a value type that is struct. And at line number 10, we are passing a object of class. So how that array list accepting both the type? Uh,
Because it takes it as type object. An object, everything that you're creating in here gets inherits from object out here.
struct and classes both. Uh,
Yeah. So struct is like a sealed class. What is a sealed class?
that cannot be further inherited.
Correct. So all structs are like sealed classes. But struct itself inherits from object. So everything inherits from object. Okay.
Okay, sir.
And
Okay,
what
sir.
is the data? What is the add taking? It's taking object. So basically you can pass any value. Anything that
That was
inherits from
I was
object.
having confusion. Like a value is object or else.
I'm saying that think of it like a sealed class because it is inheriting from one class, but it cannot be used as a base class. So think of that as a sealed class,
Okay, sir.
a struct. Okay.
Okay, sir. Thank you.
All right. Yeah. So this is one of the, searching methods for a array list. Okay, I'm going to talk about capacity right at the end. So I will cover capacity in a later example right now only, but let me first finish the others. Okay, the next one is clear. Okay, next one is clear. I'm not putting a mouse pointer on that, or I'm not going down to that because that will give you the answer. Any guesses what clear does? Any guesses what clear does?
Empty the array list.
Okay, so what is the difference between clear for a correct answer? What is the difference between clear for an array and for an array list?
In array list, it will empty it completely, and in array, it will convert the elements to default value 0.
Correct, absolutely correct. So in an array, we also saw clear, but in an array, it made all the values their default values. In the array list, when you're saying empty, it also means I'm using another word, it's deleting all the elements or removing all the elements from the array list. So why does it work differently in the array list and in the array?
So
Why
because
does it
in
clear?
array
Yeah.
we are having same data type of elements. In array list we can
No, no,
have
no, 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 no. That is not the answer.
dynamic.
As a array,
In array, we are
array is a fixed size, so we have to initialize that
So array
portion
is
to.
fixed size. You cannot remove the elements in between. But the array list is dynamic. So you can remove an element if you want to. So clear removes all elements. That is the correct answer. Deletes all elements. But it works differently from how an array works. Right. The next one is clone. Please make a note of this, of clone. Clone allows you to make a copy of that data. When you're cloning something, you're actually making a copy of that data. Right? So making a copy of that array list, but it uses a technique called cloning. And with cloning, there is, you have a concept of what is the shallow copy, and you have the concept of what is the deep copy. So there are a lot of concepts in cloning that you need to know about before you can actually try this out. If you understand how cloning works, then you can write down code for this. All right. Now, cloning is not something that is there in the syllabus. So I'm not covering cloning, but I'm also telling you that cloning is an important concept. Okay, so do read up on cloning. Even though I am not covering it, I would like you to read up on cloning. So make a note to yourself to try out cloning. What is cloning? Read up on what is a deep copy, what is a shallow copy, and be aware of these differences. If I have time at the end, I will cover concepts that I feel are important. But also, I will keep telling you this, that if I have time at the end, I will cover this. I never have time at the end. I'm always, if they tell me to finish in X number of hours, I always take X plus Y. So don't expect me to, I will tell you that if I have time at the end, I'll cover this. But I'm also telling you right now only, I never ever have time at the end. I'm always behind schedule. Okay. So I always have that fight with CDAC that they tell me, oh, you should do the course in 40 hours. I said, no, I need 100 hours. So they look at me in shock and they say, are you mad? Then they look at me and they say, no, reduce the hours. I said, okay, I will make it 80. So they say, no, 42. Then I say, no, okay, 60. They say, no, 44. So that bargaining goes up and down. And then I end up still taking more than what I promised them. So I will tell you always, if I have time at the end, I'll take it up. But I never have time at the end. So I wanted to read up on cloning. Yeah, while on that topic, I often get feedback from a lot of the batches. Sir, why are you showing us code which you're copy pasting? Okay. Frequently in the feedback, I get that suggestion. Why are you copy pasting code? You write down all the code for us. I would love to write down all the code with you. In fact, I'll love to write down, I write one line, you write one line. I love to do that. But then we'll be here for 200 hours. Not even for 100 that I asked for. We'll be here for 200 hours. So I cannot do that. I have to, some things I have to sort of speed up out here. So yeah, I agree with you that I should not be writing code by copy pasting it. I should be writing each line. I'm going one step further. I'm saying I should write one line. I'll wait for you. You write the same line. You try it out. I'll give you 5 minutes after that. Try out variations. Then we go to the next line. But if we're doing that, then CDAC course will go on for 2 years. So we cannot do that. Anyway, coming back to this obj array list dot. Here, clone, please try out. Contains returns a Boolean value. So on my left hand side, I'll be having this bool, let's say is present. And if it contains that value, it returns a true. If it does not contain the value, it returns a false. Okay. Copy 2. See what copy 2 takes as the parameter? What is it taking as the parameter here?
Array.
Array. So you can convert from a array list to an array, and one way of doing that is the copy 2. So see what I'm doing out here, creating an object array. Why object array? Why object array?
Because it contains different elements, different
Very
data
good.
types.
Very good. So object array is equal to new object. And what should be the size of this array? How many elements should I have in this object array? I want to copy the array list to an object array. So how many elements should I have in here?
Array list dot
Carry on.
by using the count method.
Array list dot count.
Count.
So yeah, why are you hesitating? Correct answer. Right? So obj array list dot count. So that will create it, and then you copy it to what? This obj array, for example. Be clear on this. So if you want to, do that, you can actually copy from the array list to the array. You have another way of doing this, right? We'll see the method as we go along. So obj array list dot, you have a two array, which also does what? See what two array returns? Also returns what? And ignore the question mark. What does it return? An
Object array.
object array. So I could now do this. Now it doesn't take a parameter, instead it returns this. So object square brackets obj arr2, let's say. So what is the difference between the two methods? What is the first and second method? What are the difference?
So first we have to declare the size on the array.
Correct. So first thing is the copy to takes the array as a parameter, whereas to array returns an object array. And in here, you would need to know, you need to create the array first, and you need to know how many elements you want to create in the array. In the second one, it simply is returning an array, so you can keep it open out here, and whatever the number of elements it actually returns. So usage is slightly different. The way in which you're using it is slightly different, but the end result is the same. What are both of these doing? Both of these doing what? Copying from where to where?
From obj array list to obj array.
Correct. And these sort of operations you might need to do a lot of times in your code also. So be familiar with this, and you should know how to use this. It could also, I mean, I'm saying this is an interview question, but there are everything that we're doing with collections are possible interview questions. Collections are very, very important in .NET, right? So you should know everything about a collection. All right. We have seen count before, equals coming in from the base class. Get enumerator, we're not using get enumerator, but this comes in from IEnumerable. So get enumerator gives you an enumerator through which you can now enumerate through objects. And this get enumerator is used by the for each loop to iterate through the objects. So we're not trying this specifically, but when we're using the for each loop, it is internally using the get enumerator. Right, get hash code again coming in from the object class. Get range. So see what get range returns. Right, what is it returning here? Here,
Array list.
array list. So if you want a subset of that array list, then you can do that. So obj array list dot get range. Again, starting at what position is the index. So let's say I'm starting at 0, and how many elements to return. Again, this is not from and to. This is how many. What is this similar to? Somewhere else that we have used this. Somewhere else we have used something similar.
Remove range.
Remove range.
Remove range. Correct. So this usage is similar to remove range, but it returns an array list. Array list. Obj arr lst2 is equal to this. It's returning an array list which contains, starting from index number 0, 3 items that will be returned out. Right, so get range done. Get type is from the base class. Index of we have done before here. Insert we have done before. Insert range we have done before. Is fixed size is read only. Now this doesn't really make sense, because is fixed size always returns false. Is it a fixed size array list? Always returns false. Is synchronize or is read only? Is it a read only array list? Always returns false. So you really don't need to use these methods. They're not really useful. Is synchronize is useful when you're using threading. So when we come to threading, and if you're using an array list, then we'll talk about this method. At this point, we're not using threading. So ignore is, all of these is methods, ignore from. Last index of you have seen, of type ignore because of the down arrow out here. Remove at remove range we have seen. Reverse we have seen with arrays. Agree?
Yes.
We are not seeing the array list, but you've seen that with arrays. So here also reverse works the same way. Sort also works the same way. Sort allows you to sort an array list. Now, if you had dissimilar data in the array list, like my array list has dissimilar data, then how will it sort it? So every object has a method called get hash code, which returns the hash code of that object. And it's like a unique number for that particular object. So it actually calls the get hash code to sort. So if you have similar data types in the array list, then it will work on those similar data types. If not, then the get hash code method can be used to sort. Okay. So reverse and sort we have seen. We have not seen set range. Okay, so I'll just write down reverse. You try it out. I'm not going to run this code in any case. Similar to what you did with arrays. Try out sort as well. And you have the set range. Just like you have get range, you have set range. What do you think set range will do? Opposite of get range, what do you think set range will do? Yes, please.
It will set the elements from
multiple
that
range.
index to a particular count.
Very well said. Okay, so basically it's overwriting the existing elements that you already have. So if I said set range of, let's say, 3, so that's the index starting from 3, and obj array list 2 I'm using. Okay, so these are the second parameter there. What is a I collection? What do you think this is going to do? Look at this line and look at this line. What do you think this will do?
Override the elements from index 3 onwards.
So here in the first line, I did what I said, take the first 3 elements and put into a new array list. And assuming I have many elements, okay, if you don't have them, it will cause you a problem. Assuming you have many elements. So you're now overwriting the next 3 elements from the first 3 elements. So if you had A, B, C, D, E, F initially, right? Here, get range of 0, 3 will get this as ABC. And then now you're overwriting from the index number 3. So now the array list will become ABC, ABC. That's what you could do out here. So play around with this, but essentially set range is overwriting the values with whatever array list that you're given.
So the
Questions?
further elements remain unaffected, right?
Yeah, whatever the number of elements that are there in OBJ array list.
Okay.
Supposing that OBJ array list had only 3 elements, then starting from index number 3, 3 elements will be overridden. Elements before and after that will remain exactly the same. All right. Sync root. Again, this is something that you will use when you're using threading. At this point, we are not using threading. So ignore that. Sync root. Okay, now the next one is very, very interesting. The this syntax also is very different if you can see out there. And that okay. So that this is using a concept called as the indexer. So what does the indexer allow you to do? The indexer allows you to access this collection in this case using a subscript. I could write this console.writeLine obj array list of let's say 0. What will this give me?
0th index
The element
object
at,
details.
yeah, element at index number 0. Or if I did this, obj array list of 0 is equal to, let's say 1, 2, 3, 4. What will this do?
It will override the previous element at 0th position.
Right? Override that with value 1, 2, 3, 4. So when you do this line, internally it is taking it as this line. Obj array list dot this of 0 is equal to 1, 2, 3. This is what it's actually doing. And this actually uses a concept called like a indexer. Right? So when you write this line of code, line number 44, internally it's converting it to obj array list dot this of 0. So see what happens when I do this, obj array list dot this. When I choose this, just see what happens. Okay, I'm pressing tab now to choose this. When I can choose this, internally it is doing what? It's removing the dot this. And this is what I can actually write down. Okay. So essentially what I'm trying to say is this, that line number 43 and 44. So you can use the array list with an index. And when you use the array list with an index, internally it is using the concept of an indexer, which I haven't shown you so far. I haven't covered an indexer with you. An indexer is like a property. Okay, and it allows you to convert any object into an object with a subscript. So I will take up an indexer with you, but in a later session. I should have actually. I could have taken it once I had tried arrays. I could have shown you an indexer, but I didn't. I'll take it up in a later session. Okay. Now that brings me to, I'm done with all the properties except for the capacity and trim to size. Yeah. So we have seen two array, two string, we know what it does. That leaves out only the trim to size. So earlier we saw there was a property called capacity. Let's try and understand how this capacity and trim to size work. Consider a situation where you're writing code out here, which we don't have that code right now, but let's say we are writing code here which says, in a loop, right? In a loop, we are saying this pseudocode, this is the actual code, read value from database, right? And add value to array list. So where is my array list being created from? By looping through the values in the database. So suppose the database had a lot of records. Let's say it had 1,000 records, 10,000 records, whatever. So 10,000 times this loop is going to run. What is it going to do 10,000 times? 10,000 times, what is it going to do? Read a value
Add
and what?
the value.
Add to an array list. So when you add to an array list, internally, this you're not doing, internally, it reallocates memory for the array list object. Agree what I'm trying to say? Every time you add to the array list, internally, what is it doing? Internally, it's keeping track of one more item for you. So it's dynamically reallocating memory out there internally. And this is doing how many times? This is doing how many times?
Infinite.
If there are 10,000 records,
10,000 times.
10,000.
So 10,000 times it is reallocating its capacity. Okay. Now in such a situation, what you could probably do is before you start looping, you set the capacity. Now, when you set a large capacity, instead of 10,000 times adding one more value to it, it now allocates a block of 10,000. It allocates a block of 10,000. And every time you add a value now, if there's enough memory, it will not keep reallocating memory internally. So this operation will be faster, would be performed faster if you do what? If you set the capacity first and then in your loop now keep adding values. And the capacity would approximately be what? Approximate. It cannot be an exact figure because it doesn't know how much data it actually requires. Approximately equal to the number of records that you have out there. Right? So it's not going to be an exact match. Now let's assume you set the capacity at 10,000 and for adding 10,000 records it requires a little more than 10,000 capacity. So what it will do is it will allocate more memory then again. It does not mean that this is the maximum memory. If you add more items, then more items will be added in any case. This does not mean that it's the maximum memory. It simply means what? It is the initial block of memory that you are getting out there so that you don't have to add items one by one and reallocate memory every time. But by no means it means that this is the maximum memory. It simply means the block is there ready for you. So now there are possibilities that at the end of your loop, you have extra capacity allocated for it. Why could that happen? Why would there be extra capacity?
If there is less elements in the database.
Correct. If the number of elements were less, that also is a possibility. Second possibility could be also what? That the number of elements in the database are more than the initial capacity that you have set. So supposing you have set a capacity of 10,000, let's say there are 12,000 records. So now what would happen now? For the extra 2,000 records, it will again allocate another chunk of 10,000. So now your capacity will be 20,000, not 10,000. For adding the extra records, your capacity has now become 20,000 because it allocates it as a chunk. So now at the end of allocating 12,000, what do you have now? You have that extra capacity remaining. So both situations, if the number of records don't match, both situations could arise. What if you had allocated extra capacity at the beginning, or what if you had allocated less capacity at the beginning? In both cases, at the end of your loop, you'll be left with some extra capacity. Now to optimize on that, you can say trim to size. So trim to size will remove the extra capacity that is there out there. Are we clear on this? So this sort of operations will happen later when you're typically adding items in a loop, for example, reading from maybe a file, reading from a database, and creating your arrays. So this is what type of code you will have to use out there. So at this time, I cannot show you that code, but be aware of what the capacity and trim to size is.
So in short, can we say that for this capacity, actually it is working like an array? Because
No,
for storing memory, it has
no,
to
no,
assign
no,
null
no,
values.
no, 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 no. Array would be fixed. Once given, then you cannot change it.
Yeah.
But here, it is just doing, see, for this you need to understand how it works. It actually does a malloc, right? It does a malloc. Malloc is a seed function. So it actually goes and reallocates memory out there. Now instead of doing it 10,000 times 111111, we are saying what? Allocate a block of 10,000. Now in an array, once allocated, you can't change it. But in a collection, even if there are more suppose you allocated 10,000 and you had tried to add more records, array would give you an error. Collection will not. Collection will say what? Okay, I'll allocate one more block out there. So it is just speeding up your work when you're trying to add records in a loop. Okay. So don't think of it like an array, because array, moment you say array, it means what? What
It
is the
will
basic difference between array and collection?
as soon as you declare the size, it will assign default
It's
values to
fixed.
it. Yeah.
Fixed. It's a fixed value. But in collections, it even if you give an initial value, it can change its value. Right? But the overhead, what is being reduced now? What are you doing with this? Reducing what overhead? The fact that you have to reallocate capacity on every record that is being reallocated, that is being saved. So anyway, that's how this would work. Are we clear on this, everybody?
Sir, at line number 46, we are allocating 10,000 block of memory to the array list. At there, what will be the size of single block? Because
That's
in array
exactly what
list,
I'm saying. That's exactly what I'm saying. That the number of records and the capacity that you've given, it is an approximate number with the capacity. It is not necessarily, because you don't know how much memory each new element will take up. Supposing you are adding strings, for example, if you add a very short string, then it requires smaller amount of memory. But if you allocate a large string, then it takes more amount of memory. So also with objects, you'll have varying data with different all memory that you have. So you can never be sure that the capacity is equal to the number of records. That's exactly the point I'm making. Understood? And which is why what are we doing at the end of it? Which is why what are we doing at the end of it?
trimming.
Trimming to size. Because what are the two possibilities? Two possibilities are, one possibility is I've allocated extra capacity. So all the capacity has not been used. First possibility could be that. So then I have to trim to size. Second possibility is what? The capacity that I've allocated is very small and all the records have not been added. So after adding all the records, let's say more records needed to be added in the loop. What is it doing now? What it is not stopping you. What is it doing now? It is increasing the capacity. So if increasing capacity by the block that you are given on the top. So what would happen again there now? What is the
Uh,
possibility now?
a
I
new
gave you the
data will be
example.
added.
I gave you the example. Let's say my capacity was 10,000 and 10,000 records were done, but I had 12,000 records. Let's say 2,000 more records to be added. So the new block being added is again now one more block of 10,000. So I have added, let's say 12,000 worth of records, but my capacity now is 20,000 has been used because 10,000 was not enough to add those 12,000 records. So now my capacity is 20K. So I have now got 8,000 ka block pending. So here also I will have to do what? A trim to size. So the point, exactly the same point I was making, that will never be exactly the same number. It will either be more or it will be less. If it is more, then you already got allocated one block, remove that extra thing. If it was less than what you needed, then it will allocate it twice. And now after allocating it twice, now you have got some extra capacity. So at the end of the loop, trim to size. Okay.
Okay, sir. Thank you.
All right. So these are some of the methods. These are some of the important methods with the array list. Let's move our example to the next example that we want to work with. So instead of an array list, I'm going to now take up a dictionary based collection, and the dictionary based collection will be using either your hash table or sorted list. So let's start with the hash table. Right. Again, you'll have basic operations that you're performing with any collection would be what? Add, remove, and number of elements that you have here would be the Yes.
Count.
Count. So when you're adding elements in your array list, you are adding only, let's say whatever values that you are adding. But here in a hash table, which is based on a dictionary, while adding it, you'll need to add two things. What are the two things for every
Key
entry?
and value.
Key and value. So let's see how we can add that. Obj dictionary dot, here also the method is add, but here it takes two things. Object key, comma, object value. Now key here says it can be of type object. That means key can be anything. And value also can be what? Of type object. It means value also can be of anything, any type of data. Are we clear on this? So, I'm going to add my keys as numeric data and value I'll add as string. While adding the key needs to be unique, but the value can be repeated. Right? So I'm just going to pick up a couple of names of the people who have switched on the video as requested. Okay, so we have Yogesh and Pratik, and I now know them. If I meet them on the road, I'll know who they are. Okay. And we have Shubham, and then we have, now suddenly people are, okay, now my name is to be added out there. Let me switch on my video. Shubham, Akshay, all right, these are the first four names that I can remember. Yogesh, right? Pratik, right? I'll correct that in a minute. And Shubham. So if I try to add the first record, this will work first, fine. Second record, will it work?
No, sir.
Sir.
Key must
Yeah.
be
Hello,
unique.
sir.
Yeah.
Key.
So the problem here is that I'm trying to add it again with the same key. And if I try doing that, let's see first what happens. So line number 67 would work correctly. But line number 68 will bomb, saying that your key cannot be the same. So key in dictionary is one, key being added is one again, you cannot add that. So I can't do that. So I have to give unique keys. Okay. All right. Now just the other day I was taking another batch and I said Shubham, and the 9 people raised their hand. So there were 9 Shubhams in that batch. I don't know how many Shubhams are there in this batch. Do we have
15
multiple
Shubham.
Shubhams in this batch? How many?
15.
15 Shubhams. My God. Acha, out of the 9 Shubhams there, 3 of them were Shubham Patils. Any Shubham Patil in this batch? No? Okay. Thankfully, there were those 3 Shubham Patils, their middle name was different. Their dad's name was different. So, otherwise, 15 definitely outscores the 9 that we had in the batch. Yeah, but there were 9 out of 120 and you all have 15 out of 240. So, yeah, roughly the same ratio, but okay, that's what we have. So anyway, so we could have duplicate keys out here. Okay. Sorry, duplicate values here. We cannot have duplicate keys. So if I try running this, this should work fine. Right? So there's no error in here. I'm not printing anything, of course. There's no error in here. All right. Let's try printing the values. Again, to print the values, I would use a for each loop. What's the collection here in this case now? Yes. Collection here in this case is your obj dictionary. Now in the earlier case, while using the for each loop, you actually use for each object item in obj array list. But here it won't be an object item. Here each entry in the dictionary is called as a dictionary entry. So there is a struct called dictionary entry. Okay. And what am I using here in this case? What is this an example of?
String interpolation.
String interpolation. So I'm saying key is, and to print the key, I have item dot. So if you look at item dot, each item has two properties. What are the two properties here? What are the, each dictionary
Key
entry
and
here
value.
has a key and it also has a value. So item dot key would give you the key and item dot value would give you the value. Are we clear on this? So this should now come out as what item dot key is 1 and item dot value is whatever the value for that. Yogesh in this
Yogesh.
case. Now if I try running this, see the order in which I've added it. I've added it in what 1, 2, 3, 4. But while printing this, it's not maintaining that order. It's coming out as what? 4, 3, 2, 1. So if you add a hash table, then the original order in which you added is not maintained. Like for example, I've added in a certain order, that order is not being maintained.
In hash table, the order will not be maintained.
Correct. Okay. Let's take a sorted list instead. And in a sorted list, the difference is it is kept in a sorted order based on the keys. So whatever way you add them, like for example, even if I had, let's say, added Pratik first, right? It doesn't matter in what order you had added them, but it is sorting it on the basis of keys. And quite often you might want to refer to sorted data rather than unsorted data. And that would be what would be allowing you to do that. So irrespective of how I've added it, now it has been sorted on the basis of the keys. Are we clear on this end? All right. Questions, Vinny?
So,
Yeah.
can you repeat the hash table effect? What is the reason this is sorted and this is not?
No, hash table is not sorted.
Yeah. What reason you mentioned, sir?
Because I'm saying that to access the values using a hash table would probably be, the way in which it's accessing would be in a random order, whereas with a sorted list, it maintains it in a sorted order, and that allows us to now write other methods which in which the order is fixed. So sorted list would give you extra features where obviously it will be more resource intensive, but it'll work probably slower. Hash table would work faster, but hash table will not be able to preserve the order. Sorted list will be able to preserve the order and would give you extra features which allow you to access it in that order.
Understood.
Okay.
Okay.
So in fact, we'll be trying out some methods out here with the sorted lists, which will not be supported by the hash table. So whatever is there in the hash table is there in sorted list, but sorted list also has extra features. And we'll be seeing them through some of the code. So we have a situation where we have adding values in here, but there's an alternate syntax that you can use, which uses the indexer. Remember the indexer? Dot this of whatever can be directly accessed in this way. Obj dictionary dot this of whatever. If I select this, it actually becomes obj dictionary of something. So I could now say obj dictionary of key, right, of key, let's say 4 is equal to a value, right? Or let's call this changed. So how is this working now? It's saying that locate the key 4 and change the value to whatever is the new value out here. Now this can be used to either change the value or add a new value. So this works in 2 ways. If it can find the key, can find the key, then what will happen now?
Change the value.
It would update the value for that key. It will update the value for the key. But if I gave a key which is not there, so this key was not there, so what will it do in this case?
Will assign a new value.
It will add a new entry. So works on two principles. Either if it found, replace it. If not found, then add it. So will this give an error? Like, if you try to do an dot add, if you said change, for example, what will happen on this line? Line number 72, what will happen in this case? Would give you an error. We tried that earlier. So you can't do it with this syntax, but you can do it with this syntax when you change the value. And it is for this reason that this syntax is preferred over the dot add syntax. So all the collections that you would work with as we go ahead would use this syntax, line 73 and 74, rather than line 68 onwards. Reason for that being what? Reason for that being what? Why is this syntax preferred?
We won't make a mistake.
Replace the keys.
It will prevent to the error.
Because both options are available. You can add an option also with this, and you can also overwrite an option with this. So if not present, add it. If already present, then overwrite. So one calls you a problem out here. Are we clear on this?
Yes.
Sir, the key should be sequential, like 1, 2, 3, 4, 5. If I add after 5, then 10.
No. See, I've added. No. I've added 2 first. No? Look at my line of code.
Okay.
Where is the sequence out there?
So anything can be okay, like 10, 20.
Your favorite number.
Okay.
As long as it's not duplicate. Okay. All right. So this is what we have done out here. All right. So if I try printing the values now, I would get what? Order would be 1, 2, 3, 4, 5. And this second Shubham that I'm referring to has been changed to changed value. Okay. And he wanted to add a different number. So he wanted to add not 5 but 50, for example. So what would this do now? 1, 2, 3, 4, and then it doesn't have to be a continuous number. All right, let's try out a few of the other methods. Now in here, you would not have a dot insert. You wouldn't have an insert. Agree? Why won't we have an insert?
Indexing is not followed by a table.
Because it is maintaining a sorted based on your, keys. So you can't say I want to insert in between this. That is not available. You don't have the dot insert option. Right? Let's look at the dot add. You don't even have a dot add range option out here. Right? You don't have a dot add range option here. You don't have an insert option here. So obviously you don't have an insert range also. So some of the methods will be different. You just add a simple one dot add out here. Let's try the removes. Now remember, there are 3 things out here. What are the 3? For every entry that you have got 3 things now that you're keeping track of. What are the 3 things?
The
Every
key
new
value.
entry here.
First
One
the
is key, one is the value, and what is the third thing? You're not doing it, but it's keeping track of that. What is that?
Object.
Value, key value, and no.
Index.
Index. At what position it is already there. So most of the methods that we'll be writing, they will tell you either give me the key or give me the index and I will give you the value. They will say what? You give me the key, I will give you the value. You give me the index, I'll give you the value. You give me the index, I'll give you the key. You give me the key, I'll give you the index. Right? And then some of them might be also looking for value, but then values could be duplicate. So they're not very, always going to give you one value. It could cause you, an issue where you don't necessarily get the correct value. But these three they will play around with: index, key, and value. You give me one, I'll give you the other. Okay. So let's start with remove. You have a dot remove, one, and you also have a dot remove at one. So can you tell me the difference between remove one and remove at one? What does remove one give you and remove at one give you? It's based on what?
Remove
one.
element. Remove element.
Remove based on key, simple.
And
Remove
remove
key
at
one.
one.
And remove at one is based on what?
Position.
Index.
Objects.
Okay, so supposing I'm writing only one at one time. Okay, I'm writing only one at one time. Remove at one, which one will it remove? Whose record will it remove?
One.
Index.
One.
Index one.
So tell me the name, no? It's
Yogesh.
easier.
Yogesh.
Wrong answer. Why Pratik?
Index
Pratik.
0 Yogesh and 1 Pratik.
Correct. So after sorting it, Yogesh will be the index number 0 and index number 1 will be Pratik. So what will be removed here will be Pratik. Similarly here, what if I did this, remove 1 in this case? Now irrespective of how I have stored it, whose record will be removed?
Yogesh.
Are we clear on this? So you have to try out all these options, is what I'm trying to tell you. I'm only talking about them. I'm not showing you the output, but you have to try it out. I'm telling you that this is how it will work. But to confirm that, is it actually working how it's working? Are we clear on this? All right. So be very, very familiar with all these methods, not just from an exam point of view, not just from an interview point of view, but even from a coding point of view, you need to know all of this. Let's look at some of the other properties here. We have seen add, as parallel we're not doing, as queryable we're not doing. Capacity we have talked about, same example as before with what we did with capacity in the previous example. You will also, capacity generally goes with what? Which other method? Capacity, and after adding all the elements, what will you call?
Trim.
Trim to size. So these same methods are there earlier, as earlier. Ignore cast. Clear, what does clear do? Come on. We've seen this in the before example. What does clear do?
Delete all elements.
Delete all elements, right? So same as before. Clear. Cloning, I asked you to read up on. Okay. Contains we've seen before also, right? What does contains do?
It returns a Boolean value.
Right. So if I contains, let's say for example, now it is now you got two things. You got a key and you got a value. So any guesses what this contains check for? The answer is there. I don't know. What does it check for?
Check for
Key
the
or
key.
value? It checks for the key, right? So for example, if I have not removed anything, then contains 1 will return 2. Now you have one more method which works exactly the same way. This contains key. So this also checks for whether the key is present or not. Both of them. This also checks for the key and this also checks for the key. Why are you getting two methods? One you're getting from the interface, from the eye collection interface. And the other one you might get from the other derived interface. Like so one you're getting from the eye collection interface, contains you're getting from there. And the other method might be there in the derived interface, in the eye dictionary interface. So which is why you'll have two different methods, both doing exactly the same thing. Okay, any guesses what the next one does? No prizes for guessing, of course. You have a contains value. Any guesses what it checks for?
Value. First occurrence.
Checks for the value. Finding out whether Pratik is there or not. If you give the answer, option out here is Shubham, then it will give you 15 times yes. In Shubham spelling. Right? X for the value. You should try out all these. I'm not going to run the code, but you can try printing it out and see. But methods, not enough time. So you're trying contains value, contains key. Copy to. What will copy to do?
Array.
Copy to an array. Now what will it copy to an array? Keys or values?
Values. Values.
Sure?
Yes, sir.
Are you sure it's values?
Yes, sir.
Yes? 100%?
Yes, sir.
So the correct answer is yes, it will copy the values. But how do you confirm for sure? You have to try it out. Try out the code and see how it works. Okay, so I'm saying values, but don't trust me. Don't trust him also. He's saying very confidently. Right? But there's no guarantee that it is the same. So please try out the code is my request. Okay, so copy to. Again, I'm not showing copy to, so we have done it in the previous example. Count we have seen equals, ignore. Okay, now the get by index, next one. Get by index. So, this is, you give me one, I'll give you the other. Right? तुम मुझे खून दो मैं तुम्हें आजादी दूंगा, that sort of a thing. So, get by index. What do you think I have to give?
Index.
Index. And what do you think it will return? Any guess? Now, two possibilities. It could return the key or it could return the
value.
Value.
So, any guesses what it would return?
It would return both.
No, it's
Both
not
can
returning
return?
both. No, it's not. It's returning. Function can return only one. No?
Then it
So
will
get by
return
index.
Key. It will return
Key.
key.
Let's see what it returns. It returns, gets the value at the specified index. So in this case, if I'm passing it the index, it's returning the value. Second one, obj dictionary dot. Look at the other gets out here. So now you have a get key. What do you think get key would do out here based on the index?
It will return the key value.
Don't say key value.
It will return the key.
Key for that particular index. So get by index is returning you the value. Get key is returning you the key. Obj dictionary dot. Let's get the other gets. Next one. Get key list. Get key list. What do you think that would return?
List of keys.
A list of keys. So how will it return this list of keys? Get key list. Answer is in the question only.
Array list.
All right, but it doesn't return an array list. It returns an I list of keys out here. So for example, on my left hand side, I have to return a I list whatever. Obj list, for example, of this. Right? Okay, now how do I iterate through this? How do I iterate through the ILIS?
Or it should be
Give me the syntax. For each in
OBJ
OBJ
list.
ILIS, and each of these elements would be of type object. Right? Your keys are of type objects. Console.write. That's how you could actually put it out. Okay. Just like you have get key lists. Like you have get key lists. You also have what? Get. What is the other one? Just like get key list. What is the other one?
Value list.
Get value. So any guesses what get value list returns?
List of
values.
Values. Syntax that you would use would be similar to what we did in here. So instead of get key list, you now use get value list. And there's one more option like this, similar to this. Obj dictionary dot keys. Right? Obj dictionary dot what? Dot what?
Keys.
No, it's not keys. It is keys. Obj dictionary dot what? What is the correct answer?
Keys.
Little more also. Keys. Similarly, you'll have obj dictionary dot values. So why am I asking you to stress on this? Because every time that you see a plural, you'll see a plural. Quite often you'll see plurals being used. Without
More
thinking,
than
you
one.
know that that is a collection. Anytime you see it ending in S, keys, values, tables, columns, rows. Every time you see the S, you know that that is a collection. Every time you think of collection, what are the things that you think of? You close your eyes and what are the three things that you think of every collection? Yeah? Every collection, what are the three things that it generally supports?
List, hash table.
Add, remove, count. Right? So you look at S ending in S, you know it's a collection. Most collections will also have what? Methods for add, remove, count, and then of course the for each loop. So you typically have this. Anyway, coming back to this. So this returns what? Keys returns a I collection. So on the left hand side, I have what now? I collection of whatever, OBJ collection. Right? Is equal to OBJ dictionary dot yes dot
Keys.
not keys. Keys, the S has to be long. Because I wanted to remember that it ends with S. Similarly, I could do what? Just like keys, I would also have what? Dot values. And then can you loop through this? I'm not writing the loop through this, but you can use a for each loop to loop through this. Let me quickly finish this. So we've tried get key list, get value list. We've tried those. We've tried all the ways in which you could get the keys and values. Next one. Now this you tell me by just listening to the name, it should tell you the answer. Index of key. Index of key. What? Explain index of key.
You enter the key value and it will return the index.
Why are you saying key value, Delhi?
You enter the key and it returns the index.
Right. So you give it the key and it will return the index. Right? Next one, index of value. Index of value, what will that do?
If you
Yes,
enter the value, it will give index.
you enter the value, but it will return the index. Now, what if we have those 15 Shubhams? Which Shubham will it refer to? Which Shubham will it
The
return?
first occurrence.
First occurrence of it. So if they're duplicate values, it doesn't give you an error, but it will give you the first one that matches. Okay, so you have to try out index of key and index of value. All of these are pretty self-explanatory. DJ dictionary dot keys done, get whatever done. Get by index. Get by index. So what is this doing? Oh, we have written get by index on top. It's written on line 83. We've done that. Okay. Index of done is fixed size. Ignore is read only. Ignore. Synchronize. Ignore. Keys we have done. Remove we have done. Remove act we have done. Set by index. Chalo, easy. Set by index. What does set by index do? Quicker answer. I'm feeling hungry. Quicker answers. Set by index. Come on. Are you all looking in there in the answer and then googling the answer and giving me the answer?
No, sir.
So set by index.
So it will set a particular value at the given index.
Perfect. Why did it take you so long to answer? So set by index requires the index that you are setting and then the value that you are setting, whatever the value. So changing the value at that given index. Okay, how do I change the value of a given key? Quick. There's no set by key. What will I do? I'm giving you the key, I want to change the value. Tell me quickly what to do. Tell me what to do quickly.
The line number 70.
Object.
So yours line number 73.
Yeah.
Object of key equal to value. Right? So that's like a set by value. Set by key rather. OBJ dictionary dot sets are done. Okay, I think we're done. So the others we have done. Sync root ignore. This is the indexer that we'll use. ToString ignore. Trim to size we have talked about, and values we have done. So just some time actually. Right. So we finished the the iDictionary based collections. Let's quickly look at iCollection. So the two that we are using there are stack and queue. And I'm not going to spend a lot of time doing this. You already know these. You'll have probably created your own stacks and queues in data structures, right?
Yes, sir. Yes, yes.
Okay. Okay. So quickly tell me what are the common methods of your stack S is equal to new stack. What are the normal operations that you'll do with the stack?
Push and pop.
So S dot push, what does it take as a parameter?
Object.
Takes object as a parameter. So S dot push, whatever values you'd like to push, right? You could push any values. How do I pop a value? S dot pop returns an object. So it returns pops the value. What's a peak? What does a peak do?
Choose the element at the top,
without
popping it,
Without popping it.
without popping it.
right? Next one, q q q कर रहे हो ये q कर रहे हो q equal to mu q. Methods with the q, typical methods, quick.
NQ, DQ,
NQ and console dot write line q dot dq,
DQ.
right? Okay. Here this also has a peak. This is a common method that you use out here. Q dot peak. Do you know what peak is? Right? These are common operations that you will perform with stack, fuse, and others. So we just covered one half of the collections. We have covered the you know, non-generic collections we have covered. What is pending?
generic collections.
Generic collection. But we'll do that after your lunch break. So what I would like you to do, I'll upload the code in the next minute or so. But I would like you all to try out these first examples in this time. I know you might have other pending work and all of that, but first try out this. Finish doing all of this so that in the next session it's really easy for you to understand what we're doing. Okay. The 4 o'clock session, 4:15 session, I'll start at 4:15 in the evening. We'll have a look at the generic connections. All right. And for now, enjoy your lunch. Don't eat too many sweets. You've got to have one more session coming up in the day. Right. And happy coding as usual. Right. See you all at
Thank you, sir.
4:15.
Thank you, sir.
4:15
Sir,
I'll start.
happy Makar Sankranti.